because of the denominator. If k is equal to 0, I can be even 1 or 2, right? So let me write down what is that. So I consider the first term is if k is 0, I is 1. It's gonna be x minus x1 divided by x0 minus x1, but this is a product. I should say multiply by. Next one is my I can be 2, right? It's gonna be x minus x2 divided by x0 because my k is still 0 minus, you tell me, x2. Because here you always have xi, right? So for this case, this is your L0. The whole thing here is your L0. So you need to tell me what is my L1 and L2, okay? So what is my L1 of x? You tell me.
X minus x1.
So first, let's simplify it. K is equal to 1. So my I is even 0 or 2 because I have 3 data points. So my I can be 0 or 2. So what is the first one? X minus x0 divided by x1 minus x1 minus x0 multiplied by x minus x2 divided by x1 minus x2. Right? So, now for the next one, for L3, 2 of x, what do I have? My k is 2, my I can be equal to 0 or 1. So that one is equal to what? X minus x0, why did I say this? My minus, okay, vertical. X minus x0 divided by x2 minus x0 times x minus x1 divided by x2 minus x1. Right? That's easy. So you got 3 L0, L1, L2, right? And now, after you have this, you have all of that, what do? You take the summation from 0 to maximum that you have, 2 of these, L of Lk of x times f of xn. So what do I do? So I say summation from 0 to n Lk of x times f of xn equals to, what do I have? First one is L0 of x. I don't write what is L0 of x. L0 of x, L1 of x, and L2 of x, you know what they are. Okay? I say L0 of x times f of x0 plus L1 of x times f of x1 plus L2 of x f of x2. Right? That's easy, huh? As long as you know how to write down your Lagrangian terms, then the rest is a piece of cake. Now tell me, if I had 4 data points, what would I do? I'm not gonna do all of them, but let's just look at the L0, when my k is 0. So when my k is 0, what choices do I have for I? 1, 2, 3. And then for the first term, when I write my L0 of x, these two are the same as how it was before. The only term that I didn't have is x minus x3 divided by x0 minus x3. As you see, when we go to higher and higher order, only our Lagrangian term multiplier because it's product of different terms. But as you see, the only x's, these are numbers. These x3, x1, x2, all of them are numbers. There are 1, 2, 3, 4, whatever. But the only number of x's that we have is 1, 2, 3. And this is for a cubic case because I have access to 4 different data points. When you simplify everything, the equation that you have is the maximum by order of 3. You have something times x to the power of 3. We don't have to simplify these things when you have it for your calculation. As you see in examples, you don't have to simplify everything and get a nice equation. You can leave it the way it is because sometimes it's easier to simplify it. Just keep it the way it is, as I showed you. But you can simply write what is L1 of x, L2 of x, L3 of x for this cubic calculation, and eventually for your function, it's the same thing, but you have another term that is L3 f of x3, and so on and so forth. So the idea is simple. You don't have any trouble. Any question? Anybody has any question? Let's look at the example and then I give you a very, very, very hard example to solve. So, let's minimize this. So let's look at the real example. The same as what we were doing previously. As the same thing as before, we are looking for a data set that we have here, and we want to know what is the velocity of our rocket at t equals to 16. As you see, we don't have t equals to 16 in our table, but we want to use the function we get and find that from there. But this time we want to use the Lagrangian method. This Lagrange method is linear, and we are doing the linear interpolation with Lagrange method to be able to predict how is the velocity. So as before, I'm using two closest data points that I have to my 16, which is 15 and 20, right? For my t, because I'm looking for t equals to 16. And by considering that I just rewrite the data points that I have, t0 and v of t0, t1, v of t1. The same as I mentioned, the next step is defining what is the Lagrangian term. I want to know what is L0 and L1. By using this formula, this is the final value that I'm going to get. That is L0 of t times v of t0 plus L1 of t times v of t1. But first I have to write what is L0 of t and L1 of t. For L0 of t and L1 of t, I write it as this. Everybody agree with this? For L0 of t is t minus t1 divided by t0 minus t1. For L1 of t is t minus t0 divided by t1 minus t0. Similar as we were talking about. It's a little too small. So after we had that, we are putting it back to the main formula that we have for Vt of x. Vt of x is our f of x eventually that we have from the result, which is the L0 of, this is our Vt which is L0 t of t times v of t0 plus L1 of t times v of t1. So when we put things together, we are able to find v at t equals to 16. So as you see, without doing any simplification, you keep the values the way they are, and simply put your t equals to 16 and find the answer that way. You don't have to simplify anything because you lose accuracy if you simplify too much. So next one is the quadratic interpolation. I'm gonna go through this pretty fast because we have been talking about it together. So for quadratic interpolation, you have 3 terms and you have to know